To answer the question of whether momentum is conserved in a 2D collision, we're going to use the Airtable apparatus. It will take a full sheet of newsprint paper to record our collision results. Be careful when removing the protective sheet and placing the newsprint. The carbon paper sheet is very delicate and easily torn. Lift the pucks straight up and down and never push them sideways unless they're on the newsprint. With the compressor plugged in and the spark timer set to a suitable value, 20 Hz or 20 sparks per second is usually the best range for the quickly moving pucks of a collision experiment. Place one puck in the center of the level table so that it remains at rest. Holding closed the switch of the spark timer, push the other puck towards the one at rest, slightly off-center, to get a glancing collision where both pucks move significantly away from the original direction of motion. Remember that the Airtable leaves a dot trail on the underside of the newsprint paper. Turn the paper over and label the dot trails of puck 1 before and after the collision, and again for puck 2. There will be a large gap between the trails of the two pucks, since the sparks come from the center of the pucks, which are quite far apart even when the edges of the pucks collide. If puck 2 was truly at rest before the collision, its before dot trail should consist of a very dark spot of many dots on the same location. For each dot trail, select a range of dots that demonstrate uniform motion. That is, the dots are in line and evenly spaced. Mark beginning and end points and draw a line through the dot trail from beginning to end. Don't just use the separation of a single pair of dots as your distance. That would be as prone to error as using just 2 data points to determine the slope of a line. Minimize error by finding the longest section of uniform motion that you can. For each line segment, measure and record the length of the line and the number of intervals between dots in the line. Don't count the dots themselves, count the intervals between the dots from beginning to end, because every interval represents an elapsed time based on your spark timer frequency setting. Extrapolate the line of puck 1 before the collision to the far edge of the paper and label this direction east or 0 degrees. The directions of the two pucks after the collision will be measured with respect to this direction. Then extrapolate the lines of both pucks after the collision backwards until they cross the first line. They will not intersect at the same location. Turning the paper so that 0 degrees is to your right, measure and record the angle of intersection for both puck lines after the collision. Finally, make sure to measure and record the mass of each puck and to record the spark timer setting. You now have all the necessary observables to carry out the investigation of whether momentum is conserved in a 2D collision.